Today's lesson will be a review lesson of some skills that you learned last year in 6th grade relating to triangles and other shapes and their perimeter and area. So you'll notice on your note page that you have some vocabulary words first. The first word that is there is the word base, which is one side of a triangle. And base and height go together, especially when we're talking about parallelograms, which include rectangles and squares and rhombuses. And the height of a parallelogram or a triangle forms a right angle with the base. So we're going to look for that little box that shows us where the right angle is in order for us to figure out which lengths of a triangle are the base and the height. The perimeter of any shape is the distance around the outside of that shape. So for a triangle, which has 3 sides, the formula for perimeter of a triangle would be the length of side 1. That's not an exponent, okay? That's a subscript that's showing it's the length of one side plus the length of the other side plus the length of the third side. So again, those are not exponents. I'm not taking anything to the second power or to the third power. I'm just showing that there are 3 sides of different lengths. So on this triangle that you see here, I would find the perimeter by adding 6 plus 8 plus 10. So I would find that the perimeter of this triangle would be 24 centimeters. Remember that in order for an answer to be accurate, it should have a number and a unit. Okay, so we're talking about, in this case, length, so my unit was centimeters. But now we're going to be talking about area, which is different than perimeter. Area is the number of square units inside of a figure. And square units is why when we're talking about area, we end up with units like feet squared, or centimeters squared, or meters squared, or miles squared. Because really what we're talking about is if I take this shape and put it onto a grid, the area is how many of these squares are inside of it. So I can measure area by counting how many squares there are inside of it. Well, this shape isn't very big, but I don't even want to count all of those squares. So we're going to use a formula to do this. This shape is a little bit easier to look at and tell that it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11 units squared. There are 11 squares inside of that rectangle. So before we move on to talk about how we calculate area, you're going to be seeing some abbreviations in your textbook and in the problems that we'll practice in class and also in this video. And the capital letter A stands for area, the lowercase letter b stands for base, and the lowercase h stands for height. And remember that on the very first page of this video, we learned the definition for base and height. When we're talking about a rectangle, to find the area, we multiply the length of the base times the height. It looks like this. I've got a rectangle, and I can tell which is the base and which is the height because my clue is this square that's telling me that's a 90-degree angle. Base and height are always connected with a 90-degree angle. They are perpendicular to one another. And when we're talking about parallelograms, well, actually, a rectangle is a parallelogram, so the formula has to be the same as what we just did for a rectangle. So you learned last year the formula for a rectangle is base times height. Guess what? That is also the formula for a parallelogram. But triangles are a little bit different, and here's why. If you look at this square that I have on my screen, half of it is yellow and half of it's green. The length of this square is 4. All of the sides, in fact, are 4. And so if I use that area formula for a parallelogram or a rectangle, because it's the same, I'm going to be doing base times height. So the area is 4 times 4, which is 16, and my units would be centimeters square. But what I notice is that a square, if I cut it in half and I take this green piece away, now I have a triangle. And what I've done is I've cut this in half. So I'm guessing that the area of that triangle is half of that 16 that I originally started with. Originally, I thought that this square had an area of 16 centimeters square. And if I did half of that, half of 16 is 8 centimeters squared. I lost that green half. So the formula for the area of a triangle is 1/2 of the length of the base times the height. Or in other words, it looks like this. Formula: A equals 1/2 BH. And that means that the area is 1/2 of the base times the height. And I can tell where the height is because it is connected with this red 90-degree angle mark. That is the height. So if they had given me on this triangle, if they had said that this length down here was 12 centimeters, and this length was 15 centimeters, and this length was 15 centimeters, and this middle thing was 10 centimeters, I would know that these 15s on the outside, I don't need those to figure out the area. All I need for area is the base and the height. And I can tell which is the base and which is the height because they are perpendicular to one another. They form a 90-degree angle. So let's go ahead and try a problem with a triangle. My formula is 1/2 base times height. Or in other words, 1/2 of something times something. In this case, I can see that the base is 7. So I'll plug in a 7 for the base. And I can see that the height is 6. And so if I do 1/2 times 7 times 6, I've got a couple of choices. I could do 7 times 6 first, which is 42, and then 1/2 of 42 would be 21. The area of this triangle is 21 centimeters squared. But let me ask if there would be an easier way to do this. 1/2 times 7 times 6. We learned at the beginning of the year about properties of numbers, and we learned about something called the commutative property. And the commutative property of multiplication and the commutative property of addition said that it was okay for us to move or change the order if we are talking about problems that only have addition or only have multiplication. In this case, these three numbers are being multiplied together. So I'm allowed to multiply them in any order that I want. I can do 1/2 times 6 in my head. What's half of 6? 3. And then I still have to multiply it by that 7. So 7 times 3 is also 21. I come up with the same answer both ways. I could also, if I wanted to, do half of 7. If I did half of 7, I would get 3.5. And then I could do 3.5 times 6, and that would also come up with 21. But if I'm looking for a method that's going to help me do some calculations in my head, I like this second method where I cut 6 in half, which is 3, and then did 3 times 7 to come up with the area. Here's another problem, and we're going to show this one step by step. I see that the base is 7 and the height is 6. So here's what it would look like in the formula using multiplication signs. 1/2 times 7 times 6, which is half of 42. And they're coming up with that same answer of 21 centimeters squared. Here's a new problem. On your note page, it asks you to write the formula for finding the area of a triangle and then to solve. So the area of this triangle, how would I find it? I'm going to do 1/2 base times height. 1/2 base times height. And if my base is 20 and my height is 10, there are lots of different ways I could solve this problem. I could do half of 20. What's half of 20? 10. And then I multiply it by this other 10, I'm going to get 100 feet squared. That's not the only way I could do this. Let me go back up here and write a different way that I could do this. What if I did 1/2 of 10? Half of 10 is 5. And 5 times 20 is 100 feet squared. And that's not even the last way I could do this. I could do this one more way. What if I did 20 times 10 first? 20 times 10 is 200. And what's half of 200? That's also 100 feet squared. So no matter what I do in this problem, I'm going to come up with an answer of 100 feet squared. Remember that the best thing about these videos is you can pause them whenever you want, go back, rewind, re-listen if I was going too fast. So now we have a problem that has a decimal in it, but we're going to solve it the same way. I've asked you to write down the formula. The formula for all these triangles is the same. Doesn't matter what the triangle looks like. We're going to be doing 1/2 base times height. 1/2 base times height. The base is 9 and the height is 6.2. Now we know that we can do many different ways here to come up with the answer. I'm going to do 1/2 times 9 in my head. I know that that's 4.5. So now I need to do 4.5 times 6.2. 4.5 times 6.2. I'd like you to come up with an answer. Please make sure that your answer has units in it, and the units should be centimeters squared, because we're talking about area. I'm talking about how many squares would fit inside that triangle. And I've got one final problem I'd like you to try completely on your own. You're going to write the formula for a triangle on your own, come up with the area to this triangle on your own, and please make sure that your answer is complete, which means it will have a number and units, and the units should be to the second power.